the consequences of this impact were global. For millions of years, dinosaurs flourished. Mammals were but tiny animals living unobtrusively in burrows. Then, totally by chance, the rules of survival changed. In the blink of an eye, the Earth plunged into darkness, then cold. But mammals then didn't need sunlight and green plants. A diet of decaying matter allowed them to survive. Were it not for this fireball, life on Earth would be different.
When I walk along these cliffs and I see this record, it actually gives me chills. I'm here today, maybe even in response to such a collision. Perhaps fireballs allowed people like us to evolve.
Before another space rock falls out of the sky, NASA has put a spacecraft in orbit around an asteroid. But what will happen when they try to land on it? At Mission Control, NEAR's thrusters have been fired, sending the spacecraft on its final descent towards Eros. 4 more braking burns are preset to fire on the craft, slowing it burn by burn to the landing spot.
Okay, this is a critical burn.
But the timing of those presets was an Earthbound guesstimate. Now that NEAR is actually in descent, calculating precisely how fast it is falling is critical to keeping the craft on course.
We just have to, between here and here, we're going to have to talk about what to do there.
Okay.
Do that.
Yes. Okay.
They have one chance to control the descent. They can reset the clock on the spacecraft's final burn sequence.
I got 0.08% under.
The question is, by how much?
I want to see if it's worthwhile. Is it worthwhile putting -6 seconds in there?
Yeah, I think it's worth it.
Okay, slight underburn brings it.
Helping the mission director determine the golden number are teams on both coasts who have been sweating this decision for months.
The most stressful moments will probably be between the first 2 maneuvers. They're about 3 hours apart, and in that time we have to determine what the first maneuver execution errors were and then upload that value to the spacecraft in order to change the second maneuver. So it's a very quick turnaround, which usually we allow days for. We're doing it in a matter of an hour or 2.
With their spacecraft free-falling towards Eros, they quickly decide to start the burn sequence 17 seconds later.
We had trouble. And we did the last burn, we started in 3.
Well, I think we got something here. If we only have to add 17 seconds, I think I got that.
Radioing this command to NEAR is the last piloting decision they can make. But if they get it wrong, NEAR will not only crash, it will rebound back into space. Because of the weak gravity on Eros, they must slow the hurtling craft so that it lands ever so lightly and sticks.
I'm really proud of the robustness of the spacecraft and the engineers who built the spacecraft, who designed it and built it. It has to be robust enough to accommodate unanticipated events. And our spacecraft has been extraordinary in that. It is a real machine.
20 seconds left in the burn.
But like any machine, it'll only do what it's told. The question is, did they tell it the right thing?
This one. X-axis is on.
Okay, got a good cutoff.
The first braking burn works perfectly. But to determine NEAR's exact location and altitude, a critical series of images will be taken from the spacecraft's outward-facing camera.
We planned these images on Friday night, and you have to hope that the trajectory is really exactly where it was predicted to be, so that when the commands execute to point the spacecraft to the right place, then you're looking at the landmarks you want to see rather than black sky.
During the descent, NEAR is snapping a photo every 30 seconds.
So where is the point where things
But waiting for those first images to show up on their screen feels like hours.
Oh, I can tell
Until
you.
there's an image, they're flying blind. The spacecraft is less than 3 kilometers from the surface. As we learn more about asteroids, there remains a more mysterious threat in the heavens: comets. The ancients saw them as signs of doom, and they weren't wrong. Scientists are realizing just how calamitous a comet could be. They look like just a fuzzy light passing sedately across the sky. But a comet is 3 times faster than an asteroid. Most continue around the sun, burning off millions of tons of ice and dust in a trail hanging in space. When Earth crosses this trail, we see a meteor shower in the sky. One of the most spectacular showers occurred in 1966, just after Comet Tempel-Tuttle passed by.